Hey everyone, welcome back to MOI Builders today. This is session 4. And quick housekeeping while people still keep joining. The recording will be up. Repo link will drop after the call ends. And yes, it's going to be the same format as usual. Um, we're gonna have the same, we're gonna have the same challenges every week. Complete today's build along, and you will earn your usual token bounty. And starting this week, we're gonna also have a standout standout submission challenge where the best submission for a separate challenge also takes home a gift card plus tokens. And I'll explain what exactly standout means at the end. But yeah, so today we're going to be building a swap, a real one, live on the DevNet. Um, Two users trading native assets directly with each other, and the headline's right there on the slide. So no pool, no deposit. If you've ever used Uniswap, you'll know why a swap normally starts by handing you tokens to a contract. And today you'll see why on MOI. That step doesn't exist at all. So before we get started, a quick recap for anyone who's new. This series has really been one idea told three different ways. MOI is participant centric. Your state, your assets, your identity, they live with you, the participant, not inside contracts, not inside applications. In session one, we saw it with logic. We saw it with Flipper versus context Flipper. Then we moved on to state. We unlocked parallel execution through the active state in session one. In session two, we saw the same idea with money. MAS0 assets are native objects on your account, and the protocol owns the accounting. And session three is where we moved on to more agentic based frameworks, where we spoke about agentic identity, registering agents on chain, and discovering other agents by themselves. Today we build on session two's native assets point, um, and we essentially point them at the most recognizable thing in DeFi, a swap. And if you miss session two, the recordings will also be linked at the end on the Luma, and today's session directly builds on it. So I'm going to stop for a couple of seconds here in case anyone has any questions about session two. All right, yeah, I mean, as usual, feel free to interrupt me at any point. Yeah, so here's the shape of the next 30 to 40 minutes. Today is going to be a pretty light session. I know the first four sessions were like conceptually heavy as well as implementation also would have taken some time. This one is more of an application, so it's going to be little lighter. So first, we're going to talk about how exactly a swap works everywhere else, on Ethereum and Solana, what the Uniswap ritual is, and every step of it exists. Then we're going to talk about the difference MOI makes, which honestly fits in one sentence. Um, then we're going to have two live builds. We're going to deploy two tokens on the DevNet, token A and token B. I've just abbreviated them as TK and TKB. And then we swap them between two wallets with the balances on screen the whole time. And at the end, your challenge. This is a build along session, so there's obviously going to be a bounty. You're going to do exactly the same thing what I'm building today on your own and get, you're basically going to get free tokens for it, which is sick. Bring your DevNet wallet if you don't have one already. Please go ahead and sign up on Voyager or MOI.Technology. It takes about 30 to 40 seconds to do so. And yeah, it's pretty simple. All right, so let's get into some theory then. Before I show you anything about MOI, any MOI version, one question about how swaps actually work everywhere else. So when you trade on Uniswap, where do your tokens actually live? By the way, for context, those who don't know what Uniswap is, it's probably the app on Ethereum that has the most volume, and uh, yeah, it's essentially an exchange where people can trade different tokens using different like mathematical mechanisms. I'm not going to get too much into the math, but more into the custody architecture. So, three facts. First, on Ethereum, a token isn't a thing you hold, and this is what we discussed in session two. It's a row in a contract storage. Your USDC balance is just an entry inside the USDC contract spreadsheet. Secondly, the pool is a shared vault. Liquidity providers deposit both tokens into one contract, and the contract holds everyone's liquidity. All at any given point in time, there's billions of dollars sitting within shared vaults. Third, every trade routes through that vault's custody. You trade with the contract and not with the person. And mid swap, your tokens are technically within the custody of the pool. There's plumbing around all this. You can do wrappers, allowances, routers, but I'm deliberately skipping it because the structural fact is simpler and it's the only one that matters today. The pool must hold tokens to trade them, and custody is the price of admission. Keep That's the most important line for the next few slides. Just keep that in your head for now. So now we're going to talk about MOI. MA0 assets, the one we built in session 2, are native objects on your account. you know um, they they don't not balance inside a smart contract, and I want to make each contrast precisely because precision is the main point here. um, there's no wrapping, and not just for our tokens. Every asset on MOI is equally native. There's no second class native coin that needs a wrapper. The asymmetry that WETH exists to patch just isn't there. No standing allowances, and this build does use a delegation primitive, lockups from session 2. But look at the shape of a lock: one beneficiary, one amount, one swap, visible on chain. And nothing is open ended here. Compare that to an ERC20 allowance that outlives the trade and sits there for a router to spend from. And when MOI dApps use mandates, those expire by default. Um, the infinite allowance problem is removed by the data model, not by an audit. No deposit, there's no pool, so there's nothing to deposit into, which is again the primary point here. So essentially on Uniswap, your tokens live in the pool's contract. On MOI, they always going to live in your account and move directly to your counterparty. Everything else today is proving that sentence, which is running code. Obviously, as we discussed in session 2, you do have the ability to uh, build logics which allow you to have shared vaults and shared storages as a developer. But as a user, we do provide the functionality for you to not have that as well. That's the beauty of this whole architecture. That for some reason, if you feel like there's a solution that might be more efficient with shared vault, you do have the flexibility to use that as well. But that's not where the power lies. So um, yeah, so here's what we're running, and the headline is that even after the upgrade, there's still not much new. These are still session two's primitives and fundamentals. Let me walk you through the actual file. So let me just okay. So like I said, today's session is gonna be really light. I'm gonna be talking through you guys with the code a little bit. But we're not gonna have like too much of code to discuss this time. I'll walk you through the first two files first. So you have the wallet files, which is I've just encapsulated this just for ease. This DApp actually involves the UI. So the wallet, the loading the wallet isn't usually like four functions. I've just done it for ease, and encapsulated the whole thing. But this is the same wallet provider that we always use. Um, Then we're gonna have two tokens that are being deployed. And again, I've just created a simple function over here: deploy asset and mint asset. And finally, we have the swap function. So before I get into this, I'm gonna quickly try to explain what we're building at a very high level. Um, what we're essentially building today is a very simple token swap. So I have token A, and another wallet has token B. Let me actually show you this with a diagram. Yeah. Yeah, so essentially what I'm building is um, I'm building a simple swap, a very simple swap. So for assume that there are two tokens, token A and token B. I've listed them as abbreviations, TK, TKB. Assume the price of or the equivalence is one token A is equal to 0.9 token B, right? Now suppose Alice, she owns 500,000 token A and Bob holds 500,000 token B. What I'm going to be building here is a simple swap where Alice can lock up how much of a token she wants to send. Bob can see that she's locked that up for Alice. Sorry, Bob can see that Alice has locked up a certain amount of tokens in Bob's name. and then Bob can claim that and also issue a transfer on the other side. I'll get into more details, but this is at a high level what's going on. Very, very simple program. I've also attached a front end on this and the capability to, you know, load your own wallet through a mnemonic on the side. So you guys can actually scaffold this repo in case you want to use it to build any front ends. Now let me just go back to the code. Yeah, yeah. Okay. So let's quickly walk through this file. At the top, I'm just going to quickly run through each function. So sendax is just a simple helper function every on-chain call uses. It just essentially pastes your receipts of each transaction. Next, we have the MA0 transfer function. Um, this is just normal token transfer. You know, you guys have done this 1,000 times before. I send you tokens and it's done. Um, we don't actually use this in the swap though, and I'll get to why in a couple of minutes. Um, then we have the lockup, um, which is essentially, you know, the like it's a slightly additional feature that we have. We're going to be talking about this this next session. Um, so instead of sending tokens, uh, Alice locks her tokens in the name of Bob or names Bob as a beneficiary. Um, yeah, so you can see, yeah, you can see asset.lockup beneficiary and amount. So over here, you'll see in the UI that you have the capability of listing your benefactor or your beneficiary, who you want to lock up the amount to. And this allows you to create conditional logic that only executes the lockup if something happens, which I'll show you soon as well. So Alice locks a token and names Bob as the beneficiary. So we have two rules, and these are enforced by the blockchain itself, not by our code. Um, one, once Alice locks, she can't take it back ever. Two, only Bob, the beneficiary, can claim it. Nobody else, not even Alice, can claim what's been locked up. It's not a promise. It's a real commitment, and it's not a promise. You can kind of think about a lockup as money in a glass box that only Bob has the key to. A real commitment, not a promise. And the catch is the shape. And the catch is that one beneficiary, one amount, and one swap. This is not a standing like allowance router that someone can spend from forever. Um, and yeah, that's essentially what lockup does. Then we have release, how you collect from a lock. Bob calls it, signs with his own key. The tokens move to him. But here's a weird catch we found while testing. Uh, we don't really have, beyond the basic like edge case tests. There's no conditional logic capability within release. So just for that, we have built claim, which is we call release through. Essentially, what claim does, which is this function right here, what claim does is three steps. It checks my balance, Alice's balance. It calls release, checks my balance again, and if it didn't go up by the right amount, nothing was really locked, and we're going to show an error at that point. So the simple idea is don't trust success, check the money actually arrived, and then initiate a settlement or a claim. And yeah, I mean, the rest are all like pretty much helper functions. Get lockups is a cool one because it's like, for example, so who do we have on the session today? We have Sujata, Sanjay, Vamshika, and Kishore. So Sanjay, suppose I were to send you like 100 ETH, right? And I were to lock it up in your name. And suppose Kishore were to also send Sanjay lock up 100 ETH in Sanjay's name as a lockup. This function essentially allows Sanjay to go through every single lockup in his name. So you can query through all of MOI's lockups and select ones that and see those ones that are specifically assigned to you as a beneficiary. And this is really cool because we can you can actually make decisions based on-chain evidence that someone's committed money to you. And obviously they can have some kind of gating based on how they want the lockup to be released. But this is a cool feature that allows you to see how many people have locked up or like who's locked up what to you as a beneficiary. And yeah, I mean, I know this is a pretty dense slide. So if you guys have any questions, I'm going to stop for 2 minutes here, take a sip of water. But the whole file in one breath, locking is enforced on chain. You can't back out, and only the right person can collect the funds. The app can see locks on chain, so claim only turns when the funds are really there. And as a backup, claim also double checks the money actually landed. The one thing this, yeah, essentially that's the main point. So I'm going to stop for a couple of minutes over here in case you guys have any questions. But keep in mind, this is not an atomic swap or a traditional DEX, and we'll get to that in the next couple of slides. All right, guys. I'm gonna get back to the demo. So basically, all of what I just showed you, it builds on to this little UI, and yeah. So yeah, before I also continue with that, I want to say quick word on the setup. I ran all the setup before the session, which involves like loading the two wallets, deploying the two assets, um, and storing all the mnemonics on file. If you guys want to play with the repo, it's just node setup.js. It does prints all the wallets for you, all the asset IDs, and automatically loads it to the envs. I only reason I did this is because we've already seen in session 2 how exactly to load a wallet, how to deploy assets, and how to mint an asset. So this is just for ease, and this is a slide I showed you earlier. So yeah, so now the swap in the card, the deal is quoted as 100 token A for 90 token B. Um, and yeah, so I mean that's one token A equals 0.9 token B, and that rate is quoted and agreed upon between the two parties, and it's no pool computed it, no curve discovered it, and what the chain sees is that there's two locks and two claims. So yeah, what I'm gonna do now is I'm gonna go to this and I'm gonna sign in with Alice's key. Yep, there we go. Um, I'm gonna paste my mnemonic over here. None of you guys can copy it from me. I'm just kidding. It's a dummy account. So I log in to my swap over here, and I see that Alice's balance is 500,000 token A, but she doesn't have any token B at all. The agreed upon quote, the rate is one token A is equal to 0.9 token B. But suppose you don't want to necessarily trust Bob, and you do want to make the swap happen. You don't want to directly send it to him and hope that he sends it to you. That's where locks come into play. At the moment, this is not an atomic swap. I've not added any conditional logic. This is very, very simple swap. So you do have to trust Bob a little bit there. But yeah, so what I'm going to do now is I'm going to select it's 100 TKA for 90 TKB, and I'm going to input Bob's public address over here. Yeah. Yes. Yeah. So while what I'm also going to do next is show you that this lockup is verified on chain as well. Yep. So you can see that Alice's balance has gone down by 100, and it says locked 100 TK for the counterparty. It's irrevocable and only they can claim it. So now what I'm going to do next is we're going to head over to Voyage, and we're going to see the latest interaction. So this is Alice's account. Um, and the operation that took place is a lockup on this asset ID. And yeah, so this is essentially on-chain proof that you actually held up to your end of the bargain. Um, so yeah, so next what's going to happen is I am going to do the same thing with Bob. I'm going to disconnect my wallet over here. Um, and then I'm gonna load Bob's mnemonic. Once again, you guys can't steal any money from Bob's mnemonic, and once again, it is a dummy account, so it's fine. So I've connected to Bob's account over here. I'm going to list Alice's public address as the beneficiary, and watch what's going to happen here. It's going to be something pretty cool. So um, yeah, okay. So before I get to that, you can see that Bob's balance is zero token A and 500,000 token B. So obviously he wants to get rid of his B and get more A. So I'm going to swap this so that he can be on the receiving end. We're going to change this to 90 because that's the agreed upon price. So Alice is going to give him 100 token A, Bob's going to give him 90 token B. And as you can see, 100 token A is locked for you on chain, ready to claim. What might have been cooler was if I added like 90, 100 token A is locked for you by this address. So we could have an extra layer of proof. But this is the point, right? This is exactly where the get lockups function comes into play. You can see that the 100 TK is already locked for you on chain, so you can fully trust that um, like your counterparty is good for the money. Obviously, there is a trust gap where they have to trust you as well, but we'll address that in a future session. So what I'm going to do right now is I'm going to hit lock 90K for the counterparty, irrevocable, and only they can claim it. And I'm going to do the boring thing again, show you on chain that this has been verified. I said boring, but this is also the most important part. Um, you go to operations, there you go, lock up on this asset ID, and yeah, you can see a bunch of other stuff here as well. Yeah, you can also see Alice's public address over here, which is this one. Yeah, you can see that she's the one who's been linked to it. Next, finally, what's gonna happen is I'm still logged in on Bob's side. Bob has locked 90 TKB and like token B, and Alice is locked up 100 token A. So once I hit claim, um, Bob's gonna claim 100 token A from Alice, and there you go. You can see the balance. Bob's lost 90 and he's gained 100. And I have to do, and I got to do the same thing with Alice as well. So once again, I'm gonna log into Alice's account, and once I enter Bob's public address as the beneficiary, we should see. Oh, the other way around. There we go. Yeah, that was the thing. Yeah. So once I hit claim, there you go. You can already see that the 100 is deducted from Alice because we already locked it up, and the 90 was deducted from token from Bob as well for token B. And once again, I'm going to show you the transaction on Voyage. So it's going to be, yeah, it's going to be release. And we're going to have that on both sides. So this is essentially the claim we were talking about, and we're going to have two of those. So it's going to be one here and one more here. Yeah, so asset ID release, participants. Yes, this is Alice's asset ID, as Alice's participant like public address, and yeah, so that's the quick workflow on this little demo. I hope you guys understood. If you have any questions, let me know. Um, yeah, and the most important point over here is that the blockchain enforces every lock. It's irrevocable. It's beneficiary only. What nothing enforces is the second lock. So Alice commits first and can't really back out. Theoretically, Bob could simply never lock his side, and that's the one remaining gap. Just hold that thought for now. Um, okay, so quick recap of what we just saw, right? Because Yeah. The question is, how does Yap know that the counterparty is locked? In this version, it doesn't. Um, yeah. Oh, sorry. I was looking at the wrong slide. Yeah. So sorry about that, guys. So let's just recontextualize what we spoke about Uniswap earlier and what we just saw. As a quick recap. Um, Native ETH must be wrapped to trade, as we discussed in session two, because it's not a token. It's a native asset, just like every asset is on MOI. There's nothing to wrap ever. Standing allowance, so the router can pull your tokens versus no approval is needed at all because transfer is push, not pull. Um, Alice sent, sorry, yeah, the main point is Alice sent tokens directly to Bob. Nothing reached, like there's no pool, there was no shared vault, there's no liquidity pool. Custody was always at my account and your account. Um, and the bottom line is the fewer moving parts is a smaller attack surface. Think about where DeFi experts actually live. So it's seen like $5 billion lost in honeypot attacks in the last 3 to 4 years, just through vaults being drained, exploiting a standing allowance someone granted like 2 years ago. And in what you just watched, there is no vault, no standing allowance, and you can't drain what was never essentially granted. So now moving on to a slightly different question, the mechanism I just showed you was just a simple swap with a little bit of conditional like logic gating, and also the fact that there's a UI is also helpful, but that's beside the point. Um, One thing we deliberately skipped, and it's the most interesting for me. It's personally the most interesting part about uh, a decentralized exchange. There's always two things about an exchange. Well, one thing that was taken for granted that we fixed, which was custody, which is architecture, which is where a pool actually, which is where your assets actually sit. Remember how we agreed upon the rate being 0.9, like one token A is equal to 0.9 token B? That's because Alice and Bob agreed on it. But on Uniswap, nobody really agrees on anything. So where does the price come from? Where is the price discovery actually? How is it actually done? What is the math behind it? Um, the pool essentially, like in Uniswap, the pool essentially holds the reserves of both tokens. So say 1,000 token A and 900 token B is in a pool. The price is essentially the ratio, so 900 over 1,000, which is 0.9. Nobody typed the number, you read it straight off the reserves, and every trade moves it. So every time the balance of, let's say, token A reduces or increases, the price becomes slightly cheaper. Basic supply and demand. So that's the entire trick. The pool is essentially your native price oracle. But catch the catch. Like this is the most interesting problem that even I think about a lot. Um, the mechanism only works because the pool custodies both sides. The vault is the oracle. Uniswap style price discovery is inseparable from the deposit model. The exact thing this whole session showed you that MOI doesn't need. Um, which sets up the interesting problem. And it's your shot at a gift card and bonus tokens. Um, how would you discover price on MOI without a custodial pool? You know, um, this is the best essentially. You can just jot your thoughts down, send me a DM, ask me any questions. But the best proposal would win a gift card for this and get featured in the next session, because this question is quite literally like the most interesting thing um, about our architecture. Like, how do you essentially do price discovery on top of MOI? And there are a few answers. And keep in mind, there is no such thing as a right or wrong answer over here. It's just a matter of architecture. Um, Obviously, like we at the team have also thought about this a lot, and we've come up with a lot of solutions which we already have. Like we already have an implementation called SafeSwap, which I'm sure I will demo to you guys one day in the future. But um, yeah, I mean, this is your chance of winning more tokens and a gift card. um, but yeah, just to reiterate the question, how would you essentially do like price, how do you discover price on MOI without a custodial pool? So just let me know what you guys think. Any questions, happy to answer. um, And yeah, and for the other challenge, which is just a simple like build along challenge, all I want you guys to do is there's going to be a form listed on the Luma. I'm also going to send it on our send it out on our groups. But basically, it's the same thing in session two, where you deploy your own asset, and you complete a two-way swap using the same lockup and release that we use today. So all I want you guys to submit on the form is you deploy those two assets, link the asset IDs in the form. I can quickly share the form as well, just to show you guys what's expected. Oh, this is the wrong one. Sorry about that. Yeah, should be sharing now. So very simple. It's just email, uh, your wallet ID, your deployed asset IDs, and the swap transaction hash. So basically, just include the when I say swap transaction hash, I'm talking about the lockups and the release. Just include the four over there, and yeah, that's pretty much the challenge for this time. The standard submission for the gift card is obviously the design. I don't expect for wait. Let me share the screen again. Keep in mind when I say I'm asking you guys for uh, solutions on price discovery for uh, exchanges on more without pools. I'm not expecting like a fully fledged out system. I would just want to understand your thinking, um, and see what kind of like ideas you guys come up with. This is not really like a test, it's more of a brainstorming and thinking exercise. So let me know what you guys think, and if potentially if it seems like a right fit, we could even collaborate and build it out as a project. That's it's a very interesting one. But yeah, I mean that's pretty much it. As always, I'm available on any channel to talk to. Monday to Sunday, any time zone. um, I'll upload the repo and the challenge form in our groups in the next couple of hours, and we should be good to go. But apart from that, if you guys have any questions, please let me know. And that was it for the session. Thank you all so much for joining. And yeah.